my videos might as well be annual at this point. Life has just hit me so hard and I've had no time, but finally I have a little bit more free time. And so what we're going to discuss in this video, we're going to look at is we're going to iterate on everything in the previous video, which is where we looked at a Y6 setup. That's 3 rotors on top, 3 rotors on bottom, 6 motors instead of 4, and we compared it to a quad. In this video, we're going to look at a 7-inch X8 setup, and we're going to be looking for 3 specific things, which are the same three factors that we've been trying to improve in the previous video as well. Number 1, an improvement in control with a craft that has larger than 5-inch props or 5.1-inch props. Number 2, a comparable level of efficiency when you have more motors and a couple more blades. And number 3, an improvement in the coaxial thrust effect, which is this weird effect where when you run a coaxial setup, it just feels like the quad is stuck in second gear. Like you have to keep pushing it forward and it doesn't really want to move forward. And it's just this weird sensation that's just not nice feeling when you want to fly. And so the first half of this video is going to be more of a summary of like kind of everything for people that aren't really interested in the nitty-gritty details. And then the second half of the video is going to be all the nitty-gritty details. And the second half is really going to be almost entirely podcast-like, so you don't really have to watch the video. But before moving on to anything, I got to show this one video from one of my friends that I talked to. I mean, I talked to like 7 pilots kind of worldwide that are full-time, only flying more than 7, but 7 on like a regular basis that are worldwide that are full-time FPV pilots. But this one guy gets the most insane jobs that I have ever seen, and he is hired to do these things. So he is flying a tiny whoop, a tiny little Cinewhoop with like an exploded GoPro. The whole thing's like 300, probably under 300 grams all up weight, over hundreds of thousands of people with fireworks and streamers and everything going on with blaring music. And I mean, people do some crazy things with FPV quads and some incredible stuff, but flying in this kind of environment, in my opinion, is just next level stress, next level kind of everything because of just what's on the line. And he is hired, he's paid to do this. And fortunately, moving forward, more and more production companies are seeing the insane value of FPV footage, so I'm really expecting it to grow from here. The pilot, if he wants to be known, I'm going to put his name in the description below. In addition, this is just his little demo reel of his flying during this one concert. The full marketing video is in the description below as well, and I strongly advise watching it. It's like a 12-minute video, but it is awesome. It's one of the best marketing videos I've ever seen, and I really hope to try and make it to this event this coming year. I think it's in August. Okay, so moving forward, looking at this quad. So the reason why we're even doing this is really just one main reason. Justin Skinner is a guy that chases fast things for his job full time. And so he's flying 7-inch quads to keep up with super trucks. And it's hard because they're really fast. And so 7-inch, the goal is to get higher cruising speed on 7-inch with improved efficiency given that you're going faster. And so what we're trying to do here is really trying to get a craft that is just better at everything and gives that high cruising speed. And my primary goal is to get a craft that has larger than 5.1-inch props that doesn't suck to fly. Now, I've been dealing with 7-inch for 5 years now, more than 5 years now, and I have never really achieved a 7-inch craft that I prefer to fly over my 5-inch craft. Fortunately, this craft happens to be just as fun, if not more fun to fly than my 5-inch because the control is there. Yeah, 7-inch is super fun because it's super fast cruising speed, but the control is actually there, which is amazing, which tells me that more motors and blades does give you more control, which is really rudimentary finding, but is definitely a finding, and it's really nice to see there. The next thing is efficiency. So this craft is using twin blades, and it has 16 blades. And the goal, or I was trying to have the same number of blades. So the goal with the Y6 setup was to have the same number of blades as a craft running tri-blades, a quad craft running tri-blades. And in that setup, it kind of worked out, gave similar efficiency. In this setup, I actually have much more motor volume and surface area and everything of the motor compared to a default quad, which I'll talk more about in the detailed portion of this video. But the efficiency seems to be comparable at this point. It's really hard to tell because it's really hard to fly just the same and consistently. I really have to give this to Justin Skinner because he has so much experience with his quads to see what his findings are, but I'm not there yet. I'm not ready to send this to him yet. And then the last thing is the coaxial effect, which is this stuck in second gear feeling. And what I've done here is that I'm running 1550 kV motors on top and 1700 kV motors on the bottom. And I chose this kV setup because I knew I was going to be running twin blades. So I thought maybe I need more kV because it's twin blades, or not thought, I knew I could run more kV. So I went with that. But then I also chose higher kV because the motors are smaller than the prototype quad that I'm comparing it to. So the prototype quad is a 7-inch quad running tri-blades with 3106.5 motor size. And this craft has our Imperial motors, which are 2506.2, which is a lot more motor volume, and there's also 4 more blades compared to the 12 blades that would be on a quad that's running tri-blades. Now, did this 150 kV increase on the bottom motors improve the coaxial effect? 100%. Absolutely, no doubt in my mind. Is that coaxial weird feeling still there? Yes, a little bit. So I would say that should be a 200 kV differential. So the next iteration of this craft is actually going to be moving down to 2306 size motors, and I'm going to be running 1250 and 1450 kV motors. So 1250 on top, 1450 kV on the bottom, and I'm going to be redesigning the whole frame to reduce weight, improve kind of everything about the frame, because it's just a test frame at this point. But yeah, it's a very promising setup, and I'm really looking forward to it. I'm really expecting to get a craft that's going to be what I'm expecting it to be. After all this testing, I'm actually moving forward and getting findings that I'm expecting to get, which is great. So now let's go over the nitty-gritty details of everything. So before talking about any of the nitty-gritty details, I want to point out that everything that I build new, I first try on Betaflight, and I have a horrible experience, and then I move to Emuflight, and the thing just magically flies totally fine. This has been my experience for about 2 years now, and I'm not going to say more about that because people defend Betaflight so much. I really don't understand why it's just so difficult. Maybe it's just me, I don't know. I mean, talking about like 50 quads here that I've tried it on, and every single quad works better on Emuflight than Betaflight, and I hate tuning anything, so I just run defaults, and everything just runs fine on Emuflight defaults. Anyways, moving forward from that. So let's first talk about the frame. This frame is a very special design, as you probably noticed, and it stems from the Sonicare frame design, which is something that I've been working on for well over a year now, year and a half now. It's in its like 8th or 9th iteration. It's actually available for sale on FPVCycle. You just have to search for the word Sonicare in the search field, and it'll come up. And so the goal of this frame is to improve the vibrational situation and the resonance of the whole thing, and just try to get a higher consistency of build. So the goal isn't to make everything amazing and try to turn off your filters and everything. That's definitely not the goal. But the goal is to have a frame that whatever you put on it, whatever build you do, you at least get a quad that flies well and consistent, which is actually quite difficult when you've sold tens of thousands of frames at this point and seen so much feedback across the board, across 7-8 years now. I really look for consistency more than anything else. In terms of being able to turn off filters and whatnot, yeah, that's going to get you like the last 2% of flight performance out of the craft. But if I can get every quad flying 90%, that's really my goal. And so this frame has these 2 spars instead of one arm to try and improve the torsional stability of the motor at the end of the arm, which it definitely does. And that in turn increases the resonance frequency of the frame. I've done tons of finite element analysis with a number of engineers, and they all kind of get somewhat close, but none of them really give me a real world comparison or a real world simulation. So you really just have to fly it in the real world, have it across several builds, and see how it goes. And that's why I've had to run a number of kind of sample runs, and I have a bunch of testers which do a really great job of giving me feedback. So this is a great frame, and the goal here again is just to get a really efficient frame. You can't just pile on weight and have like a 150 gram 5-inch frame for what? Just to be able to turn off your filters? But in turn your flight performance is going to suck because you have a bunch of extra weight that you really don't need on there. Just not worth it. So the goal here is really consistency and flight performance and getting something that is just overall a good craft. And that's what the Sonic Air is. It's probably going to be the last kind of 5-inch setup that I'm going to be working on because I'm moving on to other things as well. This frame design tends to scale really nicely. So when I scaled up to 7-inch, the overall weight and finite element analysis of it worked out really, really well, which was really super. And the carbon in the arms is also a little bit special as well. It's not that special, actually. I've tested various layups across the years, and I haven't found much improvement at all. In this case, I've just eliminated the 90-degree direction in the carbon and just made it all 45. So every single 90-degree sheet is going 45 one way or the other. And that has shown to be about a 12 to 17% improvement in resonant frequency, which is a really nice improvement, but also not huge. But because the arms are so skinny, you can get a high yield per sheet. So the overall cost is reasonable. So I can still keep the cost down, and the overall cost of having a custom layup like that, it starts to make more sense. Moving on to this frame, there is one thing that I did on this frame which is really stupid. So when I first built this thing and I first tried to fly it, there was a ton of ticks and resonant issues and just like weirdness in the craft. It just was not flying well at all, and it was all because of resonance and vibrational issues. I originally thought it might be a noise, and I added a bunch more capacitance to the ESCs. That didn't do anything. And then I flew it with just the bottom set of blades and just the top set of blades, and I noticed that only has issues with the top set of blades, not the bottom. I was using 2 different ESCs. I swapped the ESC out entirely, didn't do anything. And then I paid attention to the motor mounts on top, which are these little offset mounts. And the reason I use these are 3mm thick. The reason I use these is because it's just the most efficient way to get a coaxial setup, is to just add this little piece on the end. It doesn't add a whole lot of weight. It's really simple. And now you have a coaxial setup. What I didn't account for is that this little piece on the end, it vibrates in a certain way, which the finite element analysis did not show, a certain way that is causing like oblique oscillations in the craft. And that's the issue. And it's really hard to point this out. And people that have experience might understand what I'm saying. I hope it's clear. But basically, when something spins, you get a nice, predictable vibration. And if you have something spinning and then something else spinning in another location on top of each other, like not directly on top of each other, and also on a little extension that's like screwed into stuff that has a frequency of its own, you get an oblique vibrational pattern, which is a big problem for flight controllers. So anything that has, and the reason this is a problem in this craft and it wasn't in other crafts that I've done it with, is because this craft has a lot more power in it. If I swap this out and put 5-inch props on it, it's going to fly totally fine. And I did that too. But because I have 7-inch and the KV is a little bit too high for 7-inch and I'm running 6S, so it's got a lot of overall power in the system, that's when you start running into problems. And so next setup, definitely not going to have this offset coaxial. The offset coaxial actually is supposed to increase efficiency because you get more free air to the bottom, and so it's going to just free up everything to the bottom. It's just should fly better. But no, definitely not. Definitely going to the coaxial setup. And once I took everything apart and I greased the crap out of all the ends, just the little pieces on the end, now it flies totally fine. So then moving on to the next thing is the KV difference on the top and bottom. So there's a 150 KV differential between top and bottom. When I look at just the no load RPM with no props, I'm getting 41,000 RPM on the bottom, 37,000 RPM on the top. So that's 4,000 RPM difference with props on. I'm seeing about a 2,300 RPM differential between the top and bottom. Now the goal here was to use the same props on the top and bottom, and I'm using the GemFan 7035 prop, which is, I don't even know if it's a prop that they make. It's just a bunch of samples that they sent me. It's actually a really good prop, really nice and lightweight, and really good and wafty. It's really good pitch for all what I'm doing here. The problem with it is that it rings out when you are anything above around 1500 kV, which is kind of what I estimated at. So I can't run 1700 kV on the bottom because the props just ring out and just are getting close to exploding. So the kV is just too high. Now this craft on 5S, fantastic, but on 6S, no good. So going to be dropping the KV there, but talking about the coaxial stuck in second gear feeling, the craft is so much more freeing when it has this KV differential on the bottom versus not having this KV differential. It's just night and day, but I would say that it's not 100% gone. The next iteration, I'm going to be running 1450 kV on the bottom and 1250 kV on top. Now, we went to this X8 setup because with the previous Y6 setup, you cannot you can't fly the craft with just the top set of props or just the bottom set of props because it's only 3 props. So you're going to have a yaw moment in there, so you can't have just top or bottom. The top and bottom are tied together, so the RPM of the top and bottom are also tied together. So if you run higher KV on the bottom or more blade on the bottom, you're not going to be able to. You're not going to get a craft that flies right. It's because they're all connected. With the X8 setup, you have 2 totally independent drivetrains. They can each function independent of each other, and so you can have different KV on the bottom versus the top, and it does definitely 100% make a difference, and it is very, very, very noticeable. So in the next iteration, it's going to be a 200 kV differential, dropping the kV to try and make 6S more reasonable. But this craft itself, I actually ran it on 4S 1350 milliamp battery, and I've been trying different battery weights as well, and I'm getting like 2.5, almost 3 minutes of flight time on 4S 1350 milliamp. That's a tiny little battery. That's a 5-inch battery, and it's doing amazingly well on an X8 setup. Crazy. So that tells me that the efficiency is definitely there. I just got to get the KV kind of matched in. So talking more about the motors, let's talk about the numbers of these motors as well, because that, in my opinion, is the most interesting aspect of this whole thing. So the prototype quad that I spent years kind of going through and landing on is the 3106.5 motor. And we have that motor in stock at the store, FPVCycle. And that motor runs really good on pretty much any tri-blade, and the KV is 1420, and that's about the upper limit of the KV I would personally recommend for 7-inch tri-blades. When you start going higher, it just starts having issues with the blades, and also the amount of power in the system becomes a hassle to manage vibration-wise, electronic noise-wise. It's just not worth it. So 1420 is really the upper limit of where a motor that big should be, in my opinion, and in my personal testing only. Now, what I'm running here on this craft is 2 sets of 2506.2 motors, and that is the size of our Imperial motors. And these are the Imperial motors, just in a different KV. Now that we have all these different templates for motors, it's really nice to just experiment across all of them and making minor changes here and there. And so that's what I've been doing. I'm doing a lot of that. I got boxes full of motors that I just need to get rid of. Anyways, if you look at 2506, a pair of 2506 motors, 2506.2 motors compared to a 3106.5, a single 3106.5, the pair of 2506.2 motors is going to weigh 15 grams more, which is not good. But you have 24% more stator volume, which is a lot. And you have 54% more surface area. That means like surface area between magnets and stator. Like I subtracted the top and bottom of the cylinder of the stator. And so that is 54% more surface area interacting with magnets compared to the 3106.5. Hard to translate what that means in the real world, but to me that sounds like a really big number. And I think that has a lot to do with why having more rotors just feels so much nicer in the air than having less rotors. As in, this X8 feels as nice to fly as a 5-inch compared to the best 7-inch I've ever flown, which it doesn't compare to a 5-inch. And now I'm going to be moving to a 2306 motor size. And the reason for that is because I'm just trying to get the weight down. So compared to a single 3106.5, a pair of 2306 motors is going to weigh about 5 grams less. And it's going to have 1.6% more stator volume, which is about the same, but it's still going to have 37% more surface area. And so I'm hoping that's going to be enough and I can get the overall weight down so that I can actually skinny out the arms of the frame a little bit more. I'm going to make the thing a little bit tighter, definitely going to make it full coaxial, and I'm going to shorten the whole front because that thing is just too big. The frame is just fully experimental. So I'm going to be running 2306 with a 200 kV differential. I'm going to be aiming for 6S, might end up as 5S. KV still might be a little bit high. Overall power in the system is going to go down, so it's going to have less noise, less vibrational issues, less hassle to deal with. I'm going to be using the same props, and I'm going to be expecting everything to improve just a little bit. Maybe not the control because the motors are smaller, but overall just a little bit of improvement kind of across the efficiency board and the overall speed board because of the reduction in weight. So now talking about the batteries, I mentioned that I was running it on 4S, and I showed a video of it running on 4S, and it flew really surprisingly well. Now this thing, again, is only designed to carry a GoPro, not a cinematic thing. It could carry maybe like a real-time streaming GoPro of some sort, but no like RED camera at all. Nothing high load and no huge batteries. So it's really a light X8 7-inch that's designed to take the place of a 7-inch quad running tri-blades. And so what I found was lightening it up, even by just using a smaller battery, it actually makes the performance a whole lot better. So this is just like anything else that flies, it is weight constrained. So the goal here is to get a package that is as light as reasonable, as going to hold up to what you need it to do, and use the appropriate size battery to give you the flight time and the performance that you are aiming for. Just like everything else that you build, everything else that you do, sure, you can throw something together and it'll work, but trying to optimize it for a certain task, that's where it starts getting really, really tough. The best battery that I have for this craft is this 2200 milliamp Infinity 70C pack, which sucks. And it sucks because I've had a bunch of other 6S packs that were way better, but this pack is still the best pack compared to all the other packs that I have. And I actually got a pair of 2600 milliamp 3S 120C packs from GNB. And I was planning on using this little dongle, which kind of makes some 6S together because they're two 3S packs. And the goal here was because GNB kind of seems to drop a cell on packs that are larger than about 2000 milliamps. For some reason, their cells above 2000 milliamps just are problematic. And this is no different. This pair of packs just blows. Compared to the single crappy 2200 milliamp pack, these two pair, not good at all. And it's not the weight, because the weight is not a whole lot more. Plus you have an X8 7-inch, which has so much blade area. The weight's not going to be an issue. The whole thing has an all-up weight of 1.4 kilograms with the GoPro and everything. And so it's not the weight. It's not the connector or the wires. I'm using really substantial wiring, and the connectors are the XT90 connectors. So it's not that. Basically, what I'm trying to say here is that batteries are still up in the air. You really don't know what you're buying unless you test it, and all the batteries that we have in FPVCycle are all tested for their specific use case, and they're all very high performance batteries, and they're good. Not every company makes good batteries across the entire spectrum. So I think I've spoken long enough. I'm going to kind of wrap it up here, and I'm going to point out that I don't know if my findings are going to translate into other size crafts. I mean, I talked to a couple people that make cinelifters, and they have Y6 crafts that they lose a blade on and they don't even notice. And technically, if you lost one blade on a hex, you should definitely notice that the flight performance is beginning to suck. That might be because they're running crazy overpowered setups, but in general, it's something interesting to point out that on the Y6 that I was testing previously, which was not a weak 5-inch Y6, but it was a 5-inch Y6. If I lost one blade, that thing is spinning out of control, and maybe I have enough control to land, but it's not enough control to not definitely nowhere close to enough control to not notice. On an X8 setup, you could lose a blade or two and not even notice. I have lost 3 blades before on a flat octo, and I did not notice. After 2 flights, I finally noticed that I was missing the blades. So yeah, an X8 is going to give you a lot more redundancy. And yeah, let's just call it a day for that. And thanks for watching. Thank you so much for watching. Floss your teeth. I hope you guys have been flossing all this time that I have been reminding you. Please, please keep flossing your teeth. It's incredibly important. Okay, take care. Bye.